In this example, we're going to solve the linear differential equation x dy over dx plus 2y equals 10x squared, given the initial condition y1 equals 3, using the integrating factor technique. These problems can be done in 4 steps. We're going to start by first taking the differential equation and putting it into standard form. We do this by dividing the equation by the lead coefficient. For this equation, the lead coefficient is x, so we're going to take the entire equation and divide by x. This leaves us with dy over dx plus 2 over xy equals 10x. Now that we have our equation in standard form, we're going to find our integrating factor. The integrating factor is represented by the Greek letter mu sub x, and it is equal to e to the power of the integral of whatever value is attached to our y in the standard form equation dx. So for this particular equation, our mu sub x is going to be equal to e to the power of the integral of 2 over x dx. When we evaluate this integral, we get e to the power of 2 ln x. The natural log and e are going to cancel, the x is going to come down, and the 2 is going to remain in the exponent. So we're left with mu sub x equals x squared. X squared is our integrating factor. For the next step, we're going to multiply both sides of the differential equation by mu sub x. So we're going to take x squared and distribute it among dy over dx plus 2 over xy. And that's going to be equal to x squared times 10x. From this, we get x squared dy over dx plus 2x squared over xy equals 10x cubed. Simplifying, we have x squared dy over dx plus 2xy equals 10x cubed. This is a really important part of the process, as what we're left with is essentially the product rule on the left side of the equation. So as you can see, we have f times g prime plus f prime times g equals 10x cubed. So because we have the product side on the left side here, we're able to rewrite the differential equation as d dx x squared y equals 10x cubed. Lastly, we're going to integrate both sides of the equation, solve for y, and since we're given initial values in this problem, we're also going to solve for c. So integrating both sides, we have the integral of d dx x squared y equals the integral of 10x cubed dx. The integral cancels on the left side, and on the right side, we're simply evaluating the integral to be 10 over 4x to the power of 4 plus c. We're now going to divide out x squared on the left side, and we're left with y equals 5 over 2 x squared plus 1 over x squared c. Next, we're going to solve for c using the initial conditions that were given at the beginning of the problem. So at the beginning of the problem, we have y1 equals 3. The 1 here becomes our x value, and the 3 becomes our y value. Plugging that into our equation, we have 3 equals 5 over 2, 1 squared, plus c. So 5 over 2 times 1 plus c. Now we subtract 5 over 2 from the right side, and we're left with c equals 1/2. Now that we have our value for c, we plug it back into our original equation, and we have y equals 5 over 2 x squared plus 1 over 2 x squared as our final answer.